this lesson, we'll be looking at two examples of the binomial expansion using the binomial theorem. We have a formula there, and we're just going to jump on now to two typical questions that you would see in the exams for grade 11 or AS mathematics. First question, find the coefficient of x cubed in the following expansion. So n is 4 in this case, so we'll just follow our formula here that's just above that. So 4, so NCR on your calculator there. A is 4x. And of course we've n again, so just follow the formula for a few of these and you'll get used to it basically. And you'll start to see more. You won't even have to learn off the formula by heart or anything like that. You always want to know the why and the how of doing these things. So basically, you just get used to it by practicing more and more. B to the power of 0 is just 1, so you don't even have to write that down. Next. So a cubed, so you see it's descending, and the b, in this case 3, is ascending. We'll do one more. 4x squared, and of course for the first time we have b is squared as well, so it would have been like 3 to the power of 1 there, and so on. Now the x cubed is here. We didn't even have to go that far, so you just get used to doing them out, and you'll see you might have to finish it, but often you get asked to do the first 3 terms, something like that. So this is 4 times 4 cubed, 64, x to the power of 3, and we just have the 3 there as well. Put everything in brackets, just in case you have a negative sign. That might upset you. So we're looking for the coefficient, which is really just a number out front. So in this case, 4 times 64 times 3, which is 768, and we don't need the x cubed, so that's your answer there. That's the coefficient. So once you see that question, you might then have to equate it with other terms or coefficients. You might have to use simultaneous equations sometimes with different known values, but that would be the starting point of that. Another typical question is where you have to find the independent term, which in the name itself, but it just means where x is not involved. So x is removed. Let's do what we've been doing there with our formula. The question here seems more complex. It is in a sense, but just do it out and just follow the general formula. Don't worry about that. So once again, a is x squared, and we have the power of 4. We don't need to put in the next bit because it's just equal to 1 for term b, or variable b, and x squared again descending. So for the first time we put this in, this is b to the power of 1, and again keep going. X squared, and then so 432, and then we've x squared here as well, and of course this was minus 3 over x squared to the power of 1 to the power of 2 now. And we're going to stop there. Let's have a look. Let's do out this third term here. So this is 6. You can use your calculator to do it. X squared to the power of 2, multiply and we get 4. And this one now, minus 3 times minus 3 is 9. Careful of your minus sign. And x squared to the power of 2 is again 4. Now on our denominator and our numerator we have the same value of x to the power of 4. Remember that these are multiplying, so that cancels out. And that's the point of this question here really, is that you'll see that 6 times 9 is 54. And that's the independent term within that expansion. And here you see the expanded expression and the independent term of plus 54 in the third term.